So integration is basically it's just the opposite of the derivative. Okay, so that's why it is referred as. Sometimes it is also referred as antiderivative. So now suppose if you have got, let's say, the derivative of, let's say, ln x squared plus 5x plus 3. So the derivative of ln x squared plus 5x plus 3 is 1 upon x squared plus 5x plus 3 into 2x plus 5. So that's the derivative of ln. Now, if you suppose if you wish to integrate this, now integration is represented by the sign. So if you have the integration, so if you integrate this part with respect to x, so to represent with respect to x, you get put dx. You're going to get straight away the answer as ln x squared plus 5x plus 3. So there is another interesting thing is, so this is basically the antiderivative of this. So if they say that, okay, hence find out the antiderivative of 2x plus 5 over x squared plus 5x plus 3, then you're going to get this. So that's your answer. Now, there is another interesting thing is that suppose if I had any constant here, the derivative of that thing will be still the same stuff. So because derivative constant is 0, so you're going to get this as an answer. So you get ln x squared plus 5x plus 3 as your answer. But you need to put a plus c as a constant. So because your original function might have contained a constant, or it might not have. Like for example, even though there is plus 5, the derivative that it'll be still this. So that's why you need to be very careful of putting plus c. Now, this is basically referred as indefinite antiderivative or integration. And the second type of the question that is basically asked is see, now there are two types of integrals. When you talk about integration, there are two types of integrations. One is definite integration, and there is indefinite integration. So just to start with, if you don't have any limits on this, like suppose if you got definite integration will have a limit, indefinite will never have a limit. So that is basically about the integration types. Now I'll just take one more example of the previous type that we did. Let's say if you have got x squared plus 3 and ln x squared plus 3. So first, let's say they say that, okay, find out the derivative of this. So when you find out the derivative of this, let's see what do we get. So dy by dx is going to be x squared plus 3 into 1 upon x squared plus 3 into 2x plus ln x squared plus 3 into 2x. So that's the derivative of this. So I did u v. So I did u v dash plus v u dash. So that's the product rule, normal product rule. So this cancels, and we get the answer as derivative is nothing but the derivative of the, you can say the derivative of x squared plus 3 times ln x squared plus 3 is 2x plus 2x ln x squared plus 3. So that's the derivative of this. Now, they say that hence integrate. So suppose they say hence integrate, hence find out the integration of 2x ln x squared plus 3. So if you look here, this is a problem. Now, if I integrate this part, let's say if I integrate this part here, every term, if I integrate, so see what do we get. So integration of 2x ln x squared plus 3. This is what I need. This is what I want. So if I integrate this side, it get cancelled. Now remember that integration of x to the power n is there is a formula for it. It is x to the power n plus 1 over n plus 1 plus the constant. So if I'm integrating 2x, I can take 2 outside. It's integration of x dx. So x will be x to the power 1 here. So n is 1 So it'll be 2 times x to the power 1 plus 1 upon 1 plus 1, which is, this get cancelled again. So there's x squared. So the integration of this side, it is x squared plus 3 plus ln x squared plus 3 and plus x squared equals to, that's the integration of 2x ln x squared plus 3 dx. So this is the integration of this part basically. You bring it this side, so it become minus here. So that's your integration. And don't forget to put a constant. So this is a little advanced question, one of the exam question type questions on the integration. So just make sure that you, whenever you're doing such question, you are very well informed by each term, so that there is no confusion. So I'll just write down the other formulas also, just making sure that we understand how to integrate the other types of functions. So suppose if I have taken integration of x to the power n, I just wrote the formula is x to the power n plus 1 upon n plus 1 plus c. If you got integration of, let's say 3x cube or something, what do you do is take 3 outside first. So take 3 outside and integrate x cube. So that will be 3x to the power 4 over 4 plus c. That's your answer for this part. Now, when you're integrating, let's say this side, let's say other type of question is, if you have got ax plus b to the power n, let's say integration. Now, instead of this x, if you have replaced that with a linear function, another linear function, then how do we integrate it? So it'll be ax plus b, whenever you replace x with like a linear function, just make sure, do not change the structure, like your structural layout is same, but do not forget to divide by the coefficient of x, which is like here. So for example, if I had 3 times 5x plus 7 to the power whole 3. Now there was two different ways. You could have expanded each term and then integrated, or otherwise you could just integrate it with 5x plus 7 to the power of 4 divided by 4. This 3 remains as it is, so this 3 is outside. So 3 times 5x plus 7, here n is 3, so 3 plus 1 is 4 upon 4 into the coefficient of x, which is 5. So that's how you do this particular part. Now the next one is suppose if I'm integrating square root of 3x plus 2 dx. Now when you're integrating this part, you'll do 3x plus 2 to the power of half. So half plus 1 upon half plus 1, which is 3 by 2, into the divide by the coefficient of x, which is 3. So that's how you do this particular integrals. So just make sure that you understand and remember these formulas. We'll just take down some more formulas, which is for the other types of function. Now, if you got integration of e to the power x, integration of e to the power x, e to the power x plus c. So if this x is replaced by another linear function, which is like e to the power, suppose it's a 3x plus 5 when you're integrating, it's going to be e to the power 3x plus 5 over 3 plus c. When you're integrating, let's say e to the power 8x plus 7 dx. So this is going to be e to the power 8x plus 7 upon 8 plus c. So remember, this is just a very basic formula. E to the power x is e to the power x. So e to the power 3x plus 5 is e to the power 3x plus 5 upon 3. Similarly, integration of 1 upon x dx that you see is ln x. So plus c. Now, since we don't know the domain of x, so that's why I put absolute value. So if we got 1 over 3x plus 5, so in this case, you do ln of 3x plus 5, but don't forget to divide by the coefficient of x. So whenever you're dividing by coefficient of x, just make sure to it that this x is replaced by a linear function. If it is replaced by quadratic or something, then it won't work. This is not going to be working there. So suppose now if we got the other formula, sine x integration of sine x is negative cos x. So if you're integrating, let's say um, sine of, I'll just erase this. So if you're integrating sine of pi x plus 5, let's say, so this integral is going to be negative cos pi x plus 5 divided by pi plus c. So that's going to be the integration of this part. Now, whenever you're integrating or let's say differentiating sine and cos, just be mindful of this, which sign is positive, which sign is negative. So if you're integrating sine x, so sine x dx, if I integrate, it is negative cos x, but if I integrate cos x, it will be positive sine x plus c. So if you integrate cos of 3x minus 2, it'll be sine of 3x minus 2 plus c upon, here don't forget to divide by 3. So that's how you kind of do all the kind of integrals here. So just make sure that you understand the procedure. So let's just take a look at this example. Now here what we have got is, just in this case, you should show that this simplifies to here. So 3 over 2x minus 3 plus 3 over 2x plus 3. So if you take LCM of this, you get 3 times 2x plus 3 over and plus 3 times 2x minus 3 over 2x minus 3 times 2x plus 3. Okay, so this becomes basically 6x plus 9 plus 6x minus 9 over 2x the whole squared minus 3 squared. So minus 9 plus 9 get cancelled. So we get 12x upon 4x squared minus 9. So that's the kind of integration. I mean, that's the simplification for this part. Now then they're saying that hence integrate 12x upon 4x squared minus 9. Now 12x upon 4x squared minus 9, if you integrate, so see, to integration of 12x upon 4x squared minus 9, this is going to be same as integration of 3 upon 2x minus 3 plus 3 upon 2x plus 3 dx. So when you integrate it, so basically it becomes 3 outside, ln 2x minus 3 over 2 plus ln 2x plus 3 over 2 plus c. So this becomes 3 over 2, you can take common, and it becomes ln 2x minus 3 over 2x plus 3. So this is your integral, and arbitrary constant is plus c. So that's the answer for this part. Our next part is, they have given us a limit to this now. So just like, before I go ahead to this problem, I'll just write down the answer to this problem so don't forget. So ln 3 over 2. So this is 3 over 2 ln. So there's ln 2x minus 3. It wasn't about division actually. This is something I made a little bit of mistake. So here it is plus, so it become multiplication. So it'll be with the property ln a plus ln b. So ln a plus ln b is ln ab. So this part is going to be ln. When you write down this as a single fraction, log term. So this is 3 by 2 I've taken common. Ln is ln a plus ln b will become ln a into b. So 2x plus 3 into this. So you get 3 by 2 ln 4x squared minus 9. So this is 2x minus 3, 2x plus 3, so we become 4x squared minus 9 using a minus b plus b formula and plus c. So this part, now I'll just write in the integral 3 over 2 ln 4x squared minus 9. So that's the integration of this plus c. Now, as far as the definite integration is concerned, now, whenever you have the limits given on the top and bottom of the integral sign, that is a definite integration. Now, for example, here, if you see integration of, let's say 12x upon 4x squared minus 9, it is a limit given. So let's say limit is 2 to a. So that's your limit of the integral here. So whenever you're integrating a function, let's say a certain limit, suppose if I'm integrating a function x cubed with a limit 1 to 3, so I'm going to integrate, it will be x to the power 4 over 4, and then put the limits 1 and 3 here. So it'll be 3 to the power 4 upon 4 minus 3 to the power 1 upon 4. So it is 3 to the power 4, basically it is 81 upon 4 minus 3 upon 4. So this answer, so you first put the upper limit, this is the upper limit, this is the lower limit, and subtract the answer. So suppose if you integrate f of x and you get, suppose this is a and b, and suppose the integrated function g of x, so the answer is g of b minus g of a. So that's your definite integration. So just for this base problem, I'm just kind of use this, and as we'll cover more properties as we come across. So integration of 12x upon 4x squared minus 9 dx is going to be ln of, since we have written already, ln of 4x squared minus 9. So 3 by 2 ln 4x squared minus 9. Now I'm going to put the limit as 2 to a. So 2 to a, and equate this answer to ln pi root 5. So here we're going to put the limit. So 3 by 2, you can, so 3 by 2 ln 4a squared. So 4a squared minus 9 minus 3 by 2 ln, if you plug excess 2, so it'll be 4, this will be 4, 4 to 4, 4 to 16, 16 minus 9 is 7. So this will be ln 7. So we can equals to ln pi root 5. So we get the answer as ln 4a squared minus 9 over 7 to the power 3 by 2 is equals to ln pi root 5. Now, after this, what we do is you can just do one thing, is you can just bring 2 by 3 here. So 2 by 3 can be brought down here, and then you can raise to power. So your answer will become, so 4a squared minus 9 over 7 equals to ln pi root 5 to the power of 2/3. So ln can be removed from both the sides, and then you solve for a. So 4a squared minus 9 equals to 7 times pi root 5 to the power of 2/3. Then you solve for a, so a will be 7 times pi root 5 to the power 2/3 into, plus 9 and divided by 4, and then take the square root of this. So ideally plus or minus of it. So you can find out the value from a calculator, or since they have to write exact value, you can leave your answer out here. So now here, this is one of the favorite kind of question in additional math, where they give either single derivative or double derivative, and you have to obtain the equation of the curve. And it's like a high mountain question. So first thing is that whenever you are like given the second derivative, if you integrate that, you get the single derivative. So second derivative integration is single derivative, and single derivative integration is the function. So here you need to integrate this function twice. So what I'm going to do is I'm going to just integrate dy by dx. You're going to get dy by dx equals to, so 2x minus 5 to the power half, because negative half plus 1 is half, upon half into 2. Divided the coefficient of x, this is the 2, and plus c. So this get cancelled. So your derivative expression is square root of 2x minus 5 plus c. Now, since they have given that at x equals to 9 over 2, the slope is 6. So plug x as 9 over 2, and the gradient is 6. So dy by dx is 6. So you're going to plug dy by dx is 6, and this is root of 2 times 9 over 2 minus 5 plus c. So this get cancelled. So 6 equals to root of 4 plus c, and root of 4 is nothing but 2. So 6 equals to 2 plus c. So c is nothing but 4. So from here we get the first, like, for the derivative function is basically we got dy by dx is root of 2x minus 5 plus 4. Now our next step should be to find out the final function. So if I integrate this, I get the original function. So integration of this part is going to be 2x minus 5 to the power of 3 by 2 divided by 3 by 2 times 2 plus 4x plus c. So this 2 and 2 get cancelled, and you get with this particular part. Once again, plug x as 9 over 2 and y as 2 over 3. So 2 over 3 is 2 times 9 over 2 minus 5 uh, to the power of 3 by 2 divided by 3 by 2, 3 here, and plus c. So you get 2/3 equals to 9 minus 5 is 4. 4 to the power of 3 by 2 basically will be square root of 4, which is 2, and 8. So square root of 4 and then cube it. So power half means square root, that gives 2. So 2 cube is 8. So 8 over 3 plus c. So you get c as 2/3 minus 8 over 3, which is nothing but negative 6 over 3, which is negative 2. So your dy, so your expression for the function is going to become square root of 2x minus 5, the whole cube. I can write down like this, or you can write down in this format itself, over 3 plus 4x and minus 2. So that's your basically the final expression for the derivative function, I mean integration.